Hi class. Tonight we're going to talk about the letter E, epsilon. It represents a number, an irrational number, okay? It's 2.71828 and it continues going on forever. And to calculate the letter E, you can use this little expression here where n, as n gets larger, you get closer to E. So let me show you on your calculator. So if I plug in this expression here, 1 plus 1 over x to the x power, we can see in our table, okay, so remember what E is, approximately 2.71828. So notice as in this case x, as x gets larger, notice what y is getting closer to. Now I can jump ahead, second window, and we can jump to 5,000. Go back to our table. Okay, so 2.718. So there's that. Now that's as far as the decimals go on the calculator, but if we could see further, we could see more of the numbers on our calculator. But as you can see, as x is growing, we're getting closer to the number E. So that's how E is calculated, one of the ways. It's calculated in many ways. E is also the base of a natural logarithm. Since we haven't studied logarithms yet, you'll see that later. Some information about E. E is the base rate of growth shared by all continually growing processes. So it's a growth. That means the function is going to be increasing, and it's increasing continually. It is the base rate of growth. It's a very important number. It's not a variable. It is a number. E shows up whenever systems grow exponentially and continuously. And we'll be looking at that when we look at our applications, where they show up in the real world. So when graphing E, without using a calculator, we pretty much do the same thing we did for any other base. So if the base was 3 or 4, we have an increasing graph. Here the base is 2.71828, blah, blah, blah. And so again, we have our point at 0, 1. Why? Because e to the 0 power is 1. Our k value is 0, so we still have our horizontal asymptote. And it's increasing, so we're going to start here close to the asymptote. And once we hit that point, we curve it right up. Okay, so let's go down here to number 5. This one does not have E as the base. This one has base 3. It's still an increasing function, but we have an A value of 1/2. Okay, so normally when we would have our point at 0, 1, okay, we're going to have to take that 1 and multiply it by 1/2. So our first point would be at 0, 1/2. Our k value is still 0, so we have a horizontal asymptote at y equals 0. And we're going to curve it up at 1/2. Okay, turn it over. Let's do another one of these together. Here we have where it says write the function for the following graphs. So here we have a graph that has been translated 1, 2, 3, 4, 5 units to the right. 2 units up. So 5 right and 2 units up. So if I plug that in, we're going to have y equals, okay, we're assuming our a value is going to be 1 times our base to the x minus 5 plus 2. And then remember, we take that other point that they give us and we plug that in for x and y to solve for b. So that other point is found at 4, 6. So plugging that in, so we get 6 equals b, and then we plug 4 in. 4 minus 5 plus 2. Now keep in mind, we have a decreasing graph. So remember, our b value, keep in mind, is going to be between 0 and 1. It's a decaying function. So we're going to have, let's go over here to the side here, 6 equals b to the negative 1 plus 2. Subtract 2 on both sides. So we get 4 equals b to the negative 1. Well, b to the negative 1 is 1 over b. Then we're going to cross multiply. So we get 4b equals 1. Divide by 4. So our b value is 1/4. So the equation for this function is going to be y equals 1/4 x minus 5 and then plus 2. Okay, see you guys in class tomorrow. Hope you guys are having a good night.